dropped from a building, I think in my notes it says coin. I think on the test last semester was a banana, like so. A pumpkin is dropped from a building 1,364 feet tall. I know. When I was a little kid, I used to dream of throwing pennies off buildings, but I know it's really dark. Shouldn't have said that. Can it kill people? You all know? Like there's some physics there. Would it kill people? Or no? Okay. Yeah.
They hurt still.
Yeah. I wouldn't want to be on the receiving end, like a madman is throwing pennies off the building or something. So pumpkin. Yeah, I know. Yeah, it's all over the news, like headline news. Apparently, the idea was given to them in a calculus class. An accessory. No, don't throw pennies off buildings. So they give you this, and they'll give you the formula, which is nice. So plus, what is this thing? There we go. Plus V naught T plus S naught. So they give us that. So they give it to you, so you don't have to memorize it. Right? That makes it a little bit better. I mean, where's the negative 16 come from? I think it's because G is negative 32, right? And so 1/2 times negative 32 is negative 16. Ah, cool, right? I know. I had to think about it. Why is it negative 16? Because of this, right? Negative 32 times 1/2 is negative 16. So this is given. And so this is a nice little problem. So part A, we want to find the position function. So position function. So position function. Pretty easy problem. Position function. We'll go through all the parts slowly. So solution. So let's draw a picture and visualize what's going on. Let's try to think about what's happening. So I guess I like to draw pictures. It's fun. So here's the building, right? And here's the pumpkin. Right? And then that's the pumpkin. It's got a face on it. Okay, so and it's being dropped from a building. So the building is, how big is the building? 1364. Okay. I haven't done this in a year. Well, no, I did this last semester. I don't remember. Well, it wasn't a pumpkin though, so it's harder now. We need to figure out what this stuff is, right? So if it's being dropped, what do you think the initial velocity is? 0, yeah. So if you throw it, if it's given to you, like I take this marker and I throw it, it will be given. But it's not given, so V0 is 0. Because it's being dropped. So whenever something is dropped, it's 0. What would your initial position be in this case?
1364.
Yeah, 1364. Now I always think in my head of this, and I've never said it, but it kind of bothers me a little bit. Like, what if there's someone dropping the pumpkin? You would have to take into consideration their height too, I guess. But we'll pretend it's rolling off the building. All right, that's it. So S of t is just negative 16t squared. V naught is 0, so that's going to go away. Plus 1364. That's it. That's the position function. I know, it's pretty easy. It's not bad. Yeah.
It's like when would the V naught change to a different number?
It would give it to you.
Okay.
If it said Joey kicks a pumpkin into the air at an initial velocity of 100 feet per second,
Okay.
it would be given to you. Yes, Logan?
Do you always want it in empirical notation?
Just whatever the problem says.
It'll specify like 9.8 or 32?
No,
Or will it
well,
just give you that?
I'll just give you that.
Okay.
Yeah, I usually let the units go on this one because I always forget to put them on the test. Yeah, it's really bad. Yeah.
So if there are units on there and we don't put the units on, are you gonna?
No, I'm not. Every semester I forget to put the units on the test question. So I probably will this time too. So don't worry about it. I figured you penalize enough in physics for it, right? In physics, some teachers make you put the units in the intermediate steps, right? Like, it's like, oh, you forgot the units on step 3, game over. I'm like, yeah, no, this is math. We're okay. Velocity. Velocity. We'll be doing units later on Monday, and those problems will be given. So how do you find the velocity? What do you do here? You take the what? The derivative. Yeah, that's all you got to do. It's really easy derivatives too. Let's make it look complicated. Let's see. V of t. It's the derivative, right? So it'll be 32 times 16, so negative 32t. And, whoa, I almost messed up. What's the derivative of 1364? Zero. Did I make mistakes last time?
Yeah.
I did? Okay. We're doing double points in this class?
Yes.
Okay, all right. I don't remember making mistakes, but I believe you. I'm sure I wrote it down somewhere. I slept like 10 hours, so I'm not going to mess up today. Any questions? Yeah, I know. I went to bed before 9 o'clock. And I woke up like at 7:15, and I was so tired. I'm like, oh! Yeah, I was really tired. This one, I don't want to do it, so we should do it, because this one's in the homework. We want the average velocity over 3, 4. So find the average velocity over this interval. You will not see this on an exam. I usually don't bother with this. It's something you see in physics, and I don't know, I just never put it on the test. Which one do you have to use to find the average velocity? The position or the velocity? Position. Yeah, that's the confusing part. Right, remember the formula had the S in it. That's really tricky. That's what happened that one time I put this on a test. I felt really bad for the class. Because I purposely, and I made it a lot of points on purpose. I'm like, oh, that'd be nice. It's S of 4. Yeah. Dark times minus S of 3 over 4 minus 3. It's good I'm following my notes. Otherwise, I would forget to do this. And then you just have to be really careful because you have this, it's constant, right? It's going to cancel, but I'll show all the steps. So plugging in 4, we have negative 16, 4 squared plus 1364. That's just the S of 4, right? That's putting in the t equals 4 here. Putting in the t equals 4. Minus, and then S of 3, it's 2 terms, so I'm going to put parentheses. Okay, so it'll be negative 16 times 3 squared plus 1364. Okay, and then I think I did that right, like that. There we go. It's a little more clear. And then, there we go. Looks a little bit better. 4 minus 3 is just 1. And then I put this in my calculator. I did this beforehand. I got negative 112 as the final answer. You could check if you want. Feet per second. So, which makes sense because it's going down. So if you put all of this in your calculator, check it if you want. It should be, yeah. And it's negative because the object is falling, like the pumpkin is falling. This comes up in the homework. It's really tedious. It's one of those things. You have a lot of homework in these sections, so try to just like pick away at it slowly. Yeah.
Would it be feet per second squared?
No, that's acceleration. Yeah, because think of velocity as miles per hour or feet per second, and then if this is velocity, the rate of change of velocity is feet per second. So that's feet per second squared. Right. Does that make sense? Yeah. That has a name. Whenever you're messing with the units in physics, what is that called? Do you remember? You ever studied that? Dimensional analysis? Is that what it's called? Yeah. Yeah, I remember learning that in Physics 1. I remember my teacher, dimensional analysis. I'm like, whoa, it sounds really hard. Like,
That's what we did in chemistry as well.
Oh, you do it in chemistry?
Yeah, we did geometry.
Oh, interesting. Yeah, I've actually never studied chemistry ever. Like none. Not even in high school. No,
You're
zero.
missing out.
You should give it a try.
Yeah.
H2O with water? That's it, right? Yeah, I don't know. I have a friend who had his PhD in chemistry, but he wasn't a nice guy. So I was going to say something about him. He was really like into himself. He was just a mean person. So, he was like, chemistry is easy.
No wonder.
Yeah, he wanted to do math, but he was from France,
Did you do anything?
and in France you have to take some tests,
Yeah,
and he didn't do good enough to do math, so he did chemistry, but he secretly wanted to do math his whole life, so he was like angry about it.
Learning the acid base attraction.
On the instantaneous velocity at t equals 3 seconds. I'm just trying to do a bunch of different questions, so we're able to do the homework. I erased the velocity function. I don't know why I did that. I'm so sorry. I'll put it up here. So we had we had our position. This was our position, and our velocity was. Those are our functions, right? Is that them?
Yes.
Is instantaneous velocity on this?
No, probably not. No. So what is instantaneous velocity? It's just the derivative of velocity. It's the derivative of position, right? It's just so we just use super easy. So we just use this, right? We use the velocity function, right? Just use the velocity function. So you just is that right? By the way?
Shouldn't be prime.
Huh?
Prime?
No, it's V. I called it V, not S prime. You can call it S prime. Did I call it S prime before?
No, you called it.
Okay. So then, so just V of 3. So you just plug in 3. So it'd be negative 32 times 3. So it'd be negative 96 feet per second. I feel like I'm gonna mess up. All right, so t equals 3. So this is really easy. So instantaneous is just the velocity. Average velocity is the only one where you have to use that position function. All right, part E. Let's keep going. What's the time required? Time required for pumpkin. So for the pumpkin to hit the ground. Time required for the pumpkin to actually hit the ground. Wow, it's getting hotter in here, isn't it?
Definitely.
Yeah, it's really hot. Wow. Time. I'll shut that off in a little while once we're done with this problem, so it doesn't like blow up. So I'll have to buy another one. Time required for the pumpkin to hit the ground. So, what's going to happen when the pumpkin hits the ground? What's the position? 0. This will be on the test. So you have to set the position function equal to 0, right? So to find out how long it takes to hit the ground, you set this equal to 0. So we have negative 16t squared plus 1364 equals 0. Yeah. And then so you just subtract 1364 now, right? And so we get, this is where calculators are really awesome. And then just divide by negative 16. So divide by negative 16. Yuck. So take the square root of that number. You get plus or minus, but you only take the plus because it's time. So I got 9.233 seconds. Sorry. Someone should check that. Someone should check. It's right? It's right? Okay, cool. Any questions so far? We're building up to the harder questions. So we're just slowly building up. Okay. The last, next question. F. A, B, C, D, E, F. F. Find the velocity of the pumpkin at impact. So what is the velocity when the pumpkin hits the ground? It's called the impact velocity. So it can also say find the velocity at which the pumpkin strikes the ground. Like, sounds really intense, like strikes. Like, I just have this visual image of a pumpkin. Why'd you think of pumpkin? It's not even Halloween. Or whoever said pumpkin, wasn't it? Oh, it was you, Austin. Oh, it doesn't matter. Yeah.
This hurts.
Because of what?
Our last math teacher, we did something and we had like throw pumpkins.
Oh.
Yeah, we were like doing the math like Bravo's like to figure out like how high the pumpkin went based on how far it went.
Oh, what a fun class.
So they had, like
I want to be there. So that sounds really cool. So to find the velocity at impact, we just take the time and plug it into which function? The position function or the velocity function? The velocity function, right? Because we want the velocity at impact. So all you do is take this number and plug it in there. So it'd be V of 9.233. That's going to be negative 32 times 9.233. So I don't know what this is. I forgot my calculator. And I did it different in my notes.
Negative 295.
Okay.
0.46.
0.46? Okay. Yeah, that matches what I have actually. Good. Feet per second.